I do want to mention that today's guest, as I mentioned, is Eduardo Diaz. Next week, so we're aware of that, we're going to have uh, Lee McKnight. He's from Syracuse University. He has an extensive background in aspects of development of the internet as well. So we'll have a very interesting conversation with him. And he's an academic, so he'll bring that into the table as his background experience as well. So going back to our guest speaker, we're going to have Eduardo Diaz. He's the chair of NIRALO. He's an engineer. He goes way back to the beginning of internet services here in Puerto Rico and in the States. So, Eduardo, the floor is yours. Go ahead.
Thank you so much, Alfredo and Glenn, for having me today. I'm hearing some echo from somewhere. I don't know who that is. Maybe it's you, Alfredo. Okay, well, good morning, good afternoon, and good evening to all of you. Like Alfredo said, my name is Eduardo Diaz, and I'm talking today directly from sunny Puerto Rico, from San Juan, Puerto Rico. I am an electrical engineer by profession, and I can say that all my career have been involved with information systems, which, included the internet. Today, what I want to do is I want to take you to a trip in time and my professional career and use that just to frame this conversation about the internet and internet infrastructure and how it evolved and some specific examples how it happened. I saw a question by Kapil about regulation and telecommunication companies, being stepping stones for not proliferating internet in India, I believe. And I can give you some examples of some of those things because I started, even though I started my career with Bell Labs, I ended up in Puerto Rico working for a telephone company, but I will get there. This conversation is not all encompassing. I don't know everything that needs to be known about the internet, but I have enough to give you a view and a framework of how things happen at a macro level, and we'll be glad to answer questions at any time. Please interrupt me, Alfredo, or whoever. I want to make this a conversational type presentation. I don't have slides. I thought about having slides, but I said, no, let me talk, and then we can talk about it. It's not necessity to have slides. We can talk about this in general terms. During the presentation, you will see that many of the internet infrastructures of today were driven by demand, were driven by increased computer capacity, the proliferation of equipment, and here I'm talking about cellulars, Internet of Things, and users as a whole. And believe it or not, it also had to do with internet governance issues and even applications that's running the internet like Netflix, Facebook, and those streaming services that are the majority of the traffic of today's internet. Well, my first encounter with the internet was in 1982, believe it or not, while I was working at AT&T Bell Labs in a small town named Whippany in the state of New Jersey in the United States. That's in the East Coast. That was my first job right out of school. And the first thing that I noticed is that everybody was using email. I mean, I learned about Unix when I was there, but everybody was using email. I was able to order books. I was able to talk to send messages across the states to other research facilities around the United States at that time. And basically, our communication was based on that. Paperwork, PDF and scanners. We were using fax because we didn't have scanners that we have today. So, but most of the time we did our work using internet. We could have, we used to send files and things like that across. So that was very cool at the time. And also I remember one day when one of my colleagues came running to my office. That was in about 1992, 1983. Say, come by. I want to show you this thing, man. I was able to connect to our computer in Ohio and log in from here remotely. I said, what? He said, yes, come, follow me. And he was just so excited about this thing called the TCP/IP protocol. And I think it was in Unix, and people were talking about that. And he was, showing this connection from one computer to another, so easy to do. And I said, wow, man, this is something. I'm in the best place that I could be at that time. So by that time, that's the first time I heard about the protocol TCP/IP. In the beginning of the 1980s, that's when ARPANET started growing and having more people connected, and people started talking about the TCP/IP. Where I was working, we were using a state-of-the-art PDP 1170, running the most advanced version of the Unix operating system. Believe it, 1982. So I remember also this thing about the emails of an interconnection of research centers and university. I remember that the email, I had a friend in the University of California. I think it was in Berkeley. I don't remember where it was. And I want to send her an email. Say, well, let me try sending you an email from where I am. And, I remember how I have to find out that my email has to go through the Chicago University, and then from there I have to send it to the Texas University, and then from Texas University to her university. And in the email address, I have to put all these hops because that's how I told the system which way to go. And eventually she got my email, so it was fun. And I also used a system. It was an X400 packet switching system to send email, which work at the time, and there are many others there. So that was very, very interesting. I was very excited. It was very exciting at the time. Now, I'm telling you this story to give you context, this context that provided me with a real life knowledge about computers, information system, and as well as the internet. So let's talk about infrastructure in the infrastructure of those days. Let's move forward to 1995. From 1982 to 1995. At that time, I was working at the Puerto Rico Telephone Company, which was a monopoly that was created by law in the island to provide telephone services to all the residents in the island. There in 1995, I was tasked to create an ISP for the company to offer internet service for the public in 1995. We went into service in 1996, and it took us a year to do all these things because as a public company, we have to go to all this public bureaucracy of going to bids and getting the best price for the service, et cetera, et cetera. So it just things that you have to do for it. But in mid and by the way, I'm going to circle back to this fact later down about this bureaucratic thing because it has an effect on what I was going to say. In 1996, we started offering the service. We have two T1s lines, and T1s, as for those of you that know a little about telephony, is a 1.5 megabits line, lots of bandwidth. We got two of them going from Puerto Rico to the state of Virginia, where we connected to another network there that gave us access to the whole internet. We used to pay $10,000 US, 10,000 US dollars per T1. So we were paying per month. I'm sorry, not per year, per month. So we were paying $20,000 per month for two T1s for 3 megabits of bandwidth, man. That was a great bandwidth that we had at that time for this service. And one of the things about we talk about the internet, that when people say the internet is a network of networks, well, this is an example. Our ISP, we have a big Cisco router here where we have these two T1s coming from the United States, and we were a network connected to another network, and those other networks were connected to other networks to get information where the information resided. So that's what the internet is, a network of networks. It's not one network, it's composed of many networks. And I will get down to some of the items here and there that makes it such like that. By the way, the name of the ISP was called PRTC.net, And at that time, VeriSign was the one that managed the DNS. The .com, and was a big one on that. And we paid, I'm not talking about 1996 dollars, $75 a year for a domain, where now you can get it for $14 a year, $75 a year. So it wasn't cheap. Well, but we got all this bandwidth, right? So let's talk about telecommunications. Where we install all this equipment? Well, we found this telephone exchange, and the telephone exchange is the switch that provides services to a certain area, local area, and then from there, then you have another town, you have another exchange, and another exchange, and things like that. So in this case, we put it in exchange 285, like 77 285 1234. It's a telephone number, so it's 285 is the exchange that we put it in. We put all the computer, which was all IBM based, because IBM was the company that helped us put this thing together. We have the computers that run the email applications and the access application for the users, and we put a huge, like a whole wall of modems, like 50, 75, 100 modems, that, because at that time people were connected, they're connected to the internet using modems at 56 kilobits per second. And this is one of the things, the first things that one of the problems that we had at that time. But let me roll back a little bit. When we did the plan for the system, we thought that we were going to get 100 subscriptions a month for the following 2 years. So by the end of the 2 years, 1996, 1997, 1998, we thought at the end of 1998, we were going to have 1,200 subscriptions, because we didn't know, computer was not as proliferated. There was no cellulars. So we based the whole system on that number. And what happened is that we got the 1,200 subscriptions the first month. And by the third or fourth month, we have to stop selling. We reached capacity. It was a good, bad thing to have. And what happened? One of the things that happened is that we got people, in the telephone exchange. Remember, this is like an exchange. Like you call and you call. You can call your neighbor. You can call long distance. You can call to another town. What happened was that there were hundreds of people connected from 6 p.m. to 12 p.m. at midnight. 12 midnight, and the people in the exchange couldn't make calls outside the exchange because all the lines were occupied for 6 hours. And they could call the neighbor, but they couldn't call outside. And not only that, they couldn't receive calls because all the lines were occupied. So again, how that was solved, you distribute this access points, which was only in an exchange, across other exchanges around the island. So again, here we have demand driving the way the network was set up, meaning the access was put closer to the edge. But it was something that took us years to get to that. I am pretty sure there were many places around the world that the same thing happened. So the telecom network at that time, I remember this is access through the telephone, had this problem, how to distribute this, how to put this stuff in, new equipment coming in. And the other problem that we had is that even if you go to the edge, this telephone exchange, I don't know if you have seen them around, they're small. So you can put there just enough equipment. You cannot go over and put all the equipment that you want. It has to do with power, facilities, space. These things are in the telephone, in the telephone mentality. These things are planned 10 years before. What is going to go there, where there, and there was no space. Period. And so we got a big problems in our hand. And circling back to this bureaucratic thing that it took us a year to put in the ISP. We had this. We never catch the problem. We were putting more equipment, then we had more people. We put more equipment, we got more people. So we were in this rushing out, and things, things were rolling out in the internet, and the internet started growing, and we're behind with the equipment because things were exploding. But anyhow, so one of the first things that we found is this bottleneck in the telephone network, and I believe one of the main problems doesn't have to be going back to the question that Capil has. Sometimes it's not a regulation issue. It's a physical issue. It's the fact that you cannot put equipment there that is full. Even the lines that go to your house have problems with noise and things like that. So sometimes that happens because we think about networks and routers and connection from here to here, but there's a physical limitation in some of the telephone companies' locations. Nowadays, with the new equipment, then the switches, which used to be huge, now there are little computers that do all the switching for the exchange, so there is more space available. But that, I'm talking about in the years 1990, 2000 time frame there. So now let's go from 96 to 2000. 1999, 2000 was the year that I don't know if many of you were around, and that there was this computer, internet boom. Everybody was developing, HTML just came out. People started learning about HTML in 1995. They started making pages in HTML. They have their presence in the internet. You didn't have to ask anybody to put in a presence in the internet. They're hosting companies that you put in the internet there, your page. So there was this internet boom in 2000. And many people have it was a very creative time, and they have pages all over the place. Yahoo came to be, AOL was big. And the whole thing was the model that all these companies use was the fact that this was the medium where advertising was going to be put in, because it has a lot of eyes. The regular mediums were newspapers, TVs, and stuff like that, and they thought that this internet thing was like the greatest thing on earth, which it is. And they put, this it just grew, and really people were looking for money. They say, I put a page, people like it, bang, they buy the page from me, and then I go and I do another business. So that was the main mentality, and the base, the money base, what we support your business was the fact that you will put advertising in your page, and the advertiser will, the company's advertiser will pay you a fee for that. Well, what happened in year 2000 is that model didn't work. People found out that the money didn't come in. The advertising was minimal, and there was this this boom. It just exploded. Everybody, many companies went bankrupt. In fact, I don't know if you remember what the Sun Microsystem computers were at that time. That was a big company that was built computers. In fact, we were using at that time. We replaced all the IBM computers for Sun Microsystems, which we were more state of the art. The company disappeared. They went bankrupt, and I think it was acquired by Oracle. I don't remember which company it was, but they disappeared. A huge company with an excellent computer equipment. Why? Because it just exploded. So that time there was a glitch in innovation. People, just readjusted to these changes, and the whole thing collapsed. So, there was a rethinking of way to make money in the internet, because that's what most people want. They want to make money in the internet other than communicating and this and that. So, and one of the main problems still at that time for access was the modems. You have to connect through a modem. And I remember waiting a whole day to download a file that was, I don't know, 50, 60 millions of bytes. And, at that time, there was a lot of piracy of videos, people putting videos and music, and people downloading videos and to their web, to their computers. And it was just took a long time. So you got a line connected to a place for 2 days, just hanging in there. So, at that time, I was tasked again to bring this technology called DSL service, which is a higher bandwidth, a connection that you get to your house via the telephone line. So you can talk in the telephone, and then it uses a different spectrum within that allowed copper that goes to your house, and it's called DSL service, and that made a big difference, because now you could have internet connected all the time and not having the problem of a modem dropping out and this and that. So again, big thing for the internet, huge growth after we put the DSL service in the island. Still, it is in the island a big service, and is all and in all around the world, the service is a great service to have. Is analog to have a cable or direct connection to your house, cable which offers internet. But at that time, cable wasn't there offering internet. They were offering your services for TV and so things like that. And anyhow, even with DSL, we have problems offering service to the internet users. Because DSL, you have to put, again, the equipment at the telephone exchange where you live, close to the edge. Well, there was not space to put there, in some towns that we have in Puerto Rico, and I know it happens everywhere, there was no space in the telecom exchange to put this little box. And then if it was growing very high in that area, then there was no way of growing. So again, we got this problem of interconnection and DSL services, and eventually this got resolved with the advantage of more computing power, cloud services, and things like that. And it was now, it's integrated in the telecom equipment, and then you get the DSL service almost everywhere. Except, DSL service have a problem with the connection to your house. Even if you can get it, sometimes you cannot get it because the line that goes from the telephone exchange to your house has a lot of noise. So you cannot use it. All these things, like I said, you can have networks and networks on networks and things like that. But in the edge, you as a user, you cannot get it. And sometimes it's problems with the telecommunications that goes to your house. It could be the telecom company not able to do it, and maybe some regulatory things that I don't know about. But usually it has to do with the physical part. How do I get this to you? So this demand always have brought problems to the telephone network, and people don't think about the telephone network as such. They think about routers and lines and Wi-Fi's and things like that. But it's really, when you get down to it, it's sometimes the problem with the network at the level of the telephone company or the cable company. So with the growing of the internet through the years 2000, computers got better. In the 1980s, computers were all character-based. You didn't have that much images; it was characters, and it was because the computers were not powerful enough to manage graphics. But they got better and better and better and better. And in fact, I remember using Windows 1.0 and putting it in my computer, and I said, "Wow, this is great." So when I started using it and started opening files, the thing is starting to slow down to so much that I couldn't use the computer. I didn't install Windows at that time because the computer wasn't powerful enough. So in the 2000s, computers got better, got faster, and traffic got really, there was a congestions in the traffic in the network itself. There was, services like Netflix started to appear, and things like that. So in the network, there is something called the Inter Exchange, Ixp Exchange. I forget what the P is all about, but it's part of the network there where you many people connect to the central point and exchange traffic with each other, and including people that are connected to other networks. So and that it's really, again, every time there is this congestion, like I mentioned in the telecom company, you start pushing things to the edge. And with the IXP, you do the same thing. You start pushing things to the edge to provide traffic, local traffic that flows faster, and also to reduce costs in transmission. Sometimes remote areas are so far that going, having a line all the way to whatever, like in our case, we have to go to the States to get access to the internet. It costs a lot of money. So you put an IXP and then things locally move around, and then you go up and move upside, and then everybody uses that traffic. So internet exchange points, the PS per point, internet exchange points it's one of the network items in the infrastructure that allows this traffic to go down to the edges with this interconnections point. For example, in Puerto Rico, I believe there is a IXP, which I don't know too much about, that was put in like last year, but really we have several submarine cables that end up here in Puerto Rico, are connected everywhere. So we use one of those and we get connected to a big IXP in Florida, and that's where we connect to the rest of the network. And then I remember also with this increasing traffic and things like Netflix and sending images, and the images got bigger and bigger and bigger, more graphics. Website got really heavy in bandwidth, and then people start hearing about CDNs, content delivery networks. And what is that? Well, CDNs came out to be in 1998, and Akamai. I don't know if you heard about Akamai, the company. They started, they were very big at that time, and since 1998, now they're bigger, putting CDNs. And CDNs are like, content delivery managers, is that they will, instead of everybody going to a center, imagine millions of people going, I don't know, to the servers in California to download videos from Netflix, and millions of people around the world goes there. You know what happened? It will not happen, because traffic is not. It won't happen. I mean, it is like a denial of service. Everybody wants to connect to the server, and suddenly nobody connects because the server, they can manage that. So what they have done is they have put all this information, gets moved down to the edges to these content delivery networks that are all over around the world. And in fact, I remember in 1998, in 2000. An Akamai vendor came to my office to tell me, we want to put this equipment to where your network is. It will do this and that. I said, well, great, sure, let's do that. Well, at that time, the telephone was a monopoly, and the management had a monopolistic mind that said, if we cannot control it, we cannot put it in there. He said, well, fine, we missed that part. But anyhow, what the content delivery network does is it push all this information down to the edges. Like in Puerto Rico, we have here a CDN from Google, from Facebook, and a couple of, I'm not sure if we have one from Amazon too. So when you connect to these services, you don't really talk to a server somewhere, you're talking to a CDN, which constantly upgrades the information in the back end, okay? But basically they have a mirror of their site locally. So the traffic stays inside, it goes fast. That's why when you watch a video on Netflix, you get it right away, and it just flows because it's right there, it's next to you, or close to you. So again, traffic, congestion, demands always takes everything to the edge. That's the what happens in this distributed network, and since this is a network of networks, it allows you to do all that. So now let's talk about a little bit about the ecosystem of the internet, because I have been talking about the network, the hard. I haven't talked about the hardware because I'm not a hardware guy. I'm a more information systems guy, so I'm looking at boxes and what they do. But I want to talk a little bit about things that drive things that happen in the internet that doesn't have to do anything with end users like you and me, but it has to do with things that how the internet is governed. For example, there is ICANN. For some of you that don't know, ICANN is the in the ecosystem is one of the most important corporations. It's a multi-stakeholder corporation that set policy for the unique systems identifier. We call it the domain name system, and its main mission is to keep the security and stability of that system. There are about 13 root servers around, and this is the same for those of you that do not know about the domain name system. This is the same as saying that the telephone directory that you have in your phone, in your cell phone. When you want to call someone, you don't sometimes most probably you don't know their telephone number, but you remember their name, so you go look the name, and then it knows the telephone number. The domain name system is the same thing. We don't use names, we use names. So but computers work with numbers, so just a little telephone network, and so the DNS is just a big telephone book where they have names and telephone. They have names and IP addresses that tells you how to get a connection to that. So the DNS, it's a driving force. That's one of the key pillars within the internet that allow us to use it. You can have the best infrastructure in the world, but if you don't have that type of application that allows you to do that, it won't work. And so when we talk about infrastructure, we think about hardware and connections and cable, physical stuff. But it's a combination of everything. It's a combination of equipment and things like the CDN that I mentioned, and I also in this case systems like the domain name systems, which has such an importance that a whole organization of multi-stakeholder members develop policy to maintain this security and this stability. And the fact that, for example, when the domain was invented, it was invented in the United States and so forth. It was mainly used characters that I think characters are used in English. I don't know if it's Latin characters or how it's called, but what about the Chinese characters, Greek, Hindi, other ones? Imagine you having to learn symbols because it was invented with a different language. It was very hard. The same effort that you had to put behind putting a character that you don't know to get to a domain, the same effort somebody else that do not know English or the characters that we use to get into the internet. So you have a DNS which translates from names to numbers. And this corporation was able to introduce, and still is introducing internationalized domain names. So people in other parts of the world that speak different language could access the internet as you and me do all the time. So that inclusion to the domain name system of the IDN brought about a billion people more into the internet, increasing traffic, increasing congestion, increasing all kinds of things, which is good in the sense that more people got connected. But again, it made had an effect in the infrastructure that is being used around the world. So here you have something that is not physically hardware driving the hardware because of the needs that you need to have in order for the internet to work. And like that, there are many other organizations around in the ecosystem that have different types of effect depending of what they're doing. Like for example, Netflix. It's an application streaming video. Most of the traffic in the internet comes from Netflix and things like that. So there you have an application that is a commercial application doing hardware and network things and the infrastructure of the internet, like CDNs, IXPs, and cloud services, and all kinds of things like that. So, and then there are other organizations, and I'm talking about ICANN, which is a very important organization. I encourage all of you to become a member of the ICANN. If you're an end user, there is a large organization that you can participate, and right away when you participate, you know firsthand the type of policies that has a direct effect on the users globally related to the domain system. So you have a chance to participate and express your opinion and interest coming from the end user side if you're an end user. But there's another organization which is important here is the IETF, the Internet Engineer Task Force, IETF, which is the people that develop the protocol for the internet. And just recently, the Internet Architectural Board, which is AIB, passed a resolution or a paper, I don't remember what it was, saying that when the IETF create protocols, they should look not only in the aspect of creating the protocol for the sake of creating protocols, but what is, if I create this protocol, what effect or what kind of effect this protocol is going to have in the overall infrastructure and use of the internet. And I can give you an example. Recently, well, I don't know exactly the date, but it has been more than a year that there was a protocol called DNS over HTTP, and they call it DOH and other names, which, the idea of the protocol is to encrypt the information that you send over the internet when you are looking for a domain. So people they cannot look which sites are you're visiting or not. So they created this protocol, with this encryption thing and doing the HTML. But the effect on that is, if you look deep into what they're doing is this protocol allows is this stability. It really, this stable system that we have with the DNS, which is managed by ICANN, might get this stability. It will I don't know the word in English. It will get the stability. It will make a ripple effect in the DNS, because now that will allow private companies to own the computers that will do the DNS translation, from a name to an IP. No, it's not the root servers. It will be these computers, private computers, and you can right now, if you use Firefox, you can turn it on, and they companies like Cloudflare will go to their computers and do this translation. So, when they put together this protocol, did they look at the effect that it was going to have in the internet as a whole? I don't think so. And that's why the end user is coming into this more and more, and these protocols have to really look at the whole system before they are put out, because it's not a protocol for a protocol like that. So
Glenn, Eduardo, sorry to interrupt you, but we have a lot of questions. So
okay. Well, I wasn't interrupted, so I kept going. Go ahead. I think.
Yeah. No, you'll be able to continue as we move through the questions. I'm sorry for that, for interrupting.
I'm done.
Okay.
I was going to be. Okay.
Okay, great. So, Kapil Koyal, sorry if I mispronounced your name. He has a couple of questions, and the first one, I think you saw it. Internet is seen as critical infrastructure in developed economies. But in developing economies like India, where he is from, internet infrastructure still is an issue for regulators, government, and telcos. How can we address this challenge? Is his questions, and he suggests measurements and metrics to do something about it.
Well, this is a complicated issue. Like, the what I explained at the beginning about issues that telecom company they have about not having space to put equipment and not being able to address issues of the connection between the exchange to your house and things like that. It's part of the problem. In fact, nowadays, most of the internet is going to be done via 5G networks, old wireless. Copper is not going to be used going forward. Wireless will be the way of getting access to the internet. Now, the best way of going to this is through the government. If there are regulations that are stopping innovation or not allowing access to whatever, because there is a law or regulation that impedes for you to get it, well, you have to go and work on that, because sometimes laws are created for X, Y, and reason, and they need to be changed because they have to be brought up to our days. That's what I can say about that. I don't know if I answered
Great.
the question as
Yeah.
well.
Thank you for that, Kapil. If you have a follow-up question, just write it in the chat, and I'll get back to you. Another question that Kapil has is related to the impact the COVID pandemic has had. His question is: the pandemic has given great challenges for people from different sectors, especially for faculty members from academia. Seamless and ubiquitous internet connectivity is still a big concern. And his question is, how can we address infrastructure challenges for the next billion citizens that will be connected?
Well, the network is one issue. Being able to connect to the network, and like I said, most of the things happening going forward is you're going to get internet access via wireless. Now, how telephone companies will put the networks where they can make money. If there is not enough money, the government has to jump in and subsidize that type of communication. If that money is not there, it's not going to happen. Another idea is to use community networks. You bring internet from one point to another point, and then in that point you distribute the network, and the same community provides internet to whatever area, remote area is there, and that's happening. It's happening everywhere. And also, the other problem that doesn't have to do with the internet is, does everybody have access to a computer and or a device that can connect to the internet? And then on top of that, once I have it, do I know how to use it? Who shows me? Who teach me how to use it? And it goes both ways. Goes to the end user using the internet, and in this case, if we take the long distance learning, to the teachers that are teaching this. And then on top of that, is it the way they're teaching this and long distance is the right way of doing it? I don't know. So it's a very complex issue. It's happening everywhere. It's happening here in Puerto Rico. Even in this small island, there are many students that do not have access to the internet, and those that have it, they don't have the device to connect to the internet, and it will have a repercussion going forward in the years to come because of this gap in knowledge that the students will get through these years of COVID.
Thank you, Eduardo, and for those of you that are here in the IGF that we're going to have in November. I will be giving a short presentation on the impact that COVID has had on education here in the island, and we'll have other people talking about that issue as well. If I recall, it's going to be session 107, so look out for that one. Rola has a question, and I need to give some background information for this one. If I recall, it was last week that there was a webinar from the Internet Governance Project in Georgia Tech. The moderator was Milton Mueller, and Andrew Sullivan from ISOC, the president and CEO, was there. And if I recall, Malik was also the other panelist. And they were talking, the question was regarding a new IP, a new Internet Protocol system. So Rola's question is, she wonders what your perspective and opinion is on this new IP concept. Go ahead.
Well, okay, but my opinion is I'm going to give an analogy. Let's say we all speak English, millions and millions of us. Now we have to start learning Esperanto. It's a different language. It's a different network, a different way of communicating. Yes, it could be that new protocols and new IPs will be better today to manage these new innovations that are happening constantly. But the TCP/IP, even now is being during the COVID it's has been resilient. I mean, it's working everywhere in the sense that it's traffic is being managed, and like I said, this equipment that is being put out there, they have been increased and it's being managed. So we can talk about new IPs, and one of the big problems is the same thing that happened with IPv4 and IPv6. Why is it IPv6 since was invented at the end of the 1990s? Hasn't been that everything is IPv6 now? Because there's a lot of money invested in the network, millions and billions of dollars of billions of computers, and everything that is embedded in the network to change in order to manage IPv6, to move from one to the other one. And then the fact that you have this dual stack that you can manage IPv6 and IPv4. Why I'm going to change? Why? Is it working? So it's this. Some people say, if it's working, don't touch it. So the same thing with the new IP. If it's working, so yes, good IP. Yes, I have a watch now that I can put it in my hand. Sure, that's very good. So I'm still using TCP/IP. So I don't think something like that is going to happen soon. People might talk it at an academic level, but I don't think practically it's going to come down. Not at least during my lifetime. I don't know if in the future something else happens. But TCP/IP it has been very reliable, and it, like I said, it's a protocol that everybody uses, and it's being used right now. We're using it, and it works. That's my interpretation. Maybe I'm wrong.
Okay, thank you for that, Eduardo. And I'm going to skip a couple because they are related to what you just said in relation to the new IP and what is the functionality between IPv4 and IPv6. But then there's another interesting question by Rudolph Daniel Rudy, better known as Rudy. He's asking, what is the relationship between IAB and the ITU as far as it relates to internet standards and future development of protocol and standards? Interesting question.
Yeah, very interesting question. I really don't know. I don't have enough knowledge about that type of relationships and the ITU and between the IAB and the ITU to answer that question. I don't follow those tracks. So sorry if I'm not able. Maybe somebody else that is within the group can answer that question. I don't have the knowledge to answer it.
Yeah, well, I don't know. I have even less knowledge than you do, Eduardo. But I understand that the ITU is more of a multi-stakeholder organization where they get together and they establish some principles in order to work on some sort of standards and future development. It's more the IAB that does the protocol stuff and the technical aspects of that. It's sort of like the IEFT or the IFTF, whatever. I forget the order. So one is more technical and one deals, as Glenn mentions, with the procedures or the RFCs, which is the document that establishes the process or the policy that is going to be used. So yes, one is more technical, one is the principle of what the technical people should to do. The problem with that is that, as you mentioned, Eduardo, they forget about the end user. Those that are too technical are dealing with the innovation, with the infrastructure, with the development, and forget that us, the end users, especially those that are people from underserved or underdeveloped countries, don't have the organizations to build the infrastructure to gain access to those innovations. So that's the biggest problem, and you pinpointed accurately when you mentioned how are we going to deal with getting the internet to the next billion people. It all depends on the governments and policies that they can implement in order to reach out to all the registries, registrars, and internet service providers to get the infrastructure out to those people that need it. I do have more questions, but I don't know if we actually have enough time. So let me go through a couple. And these are, I'm sorry for you guys, but these are questions that I've been thinking about. Uh, one question is the Internet of Things seems to be taxing the DNS. I mean, there's a lot of devices out there that are using IPs, and, and as a result, well, the DNS is getting saturated. How do you foresee the industry uh, enhancing the stability and security of the DNS? Are they actually working on
Well,
policies or regulations to do that?
uh, well, one of the things with this DNS stress, it really happens when there's this botnet attacks where you have millions of IoTs doing this huge denial service attack where they're using the DNS all at the same time. So it stressed the DNS. Other than that, the IoT just it's like another computer and uses the DNS like you and everybody else uses it. But when they have these attacks, then it creates a stress in the DNS. So one of the thing is the companies that produces these IoTs are being educated in making sure their systems are safer to use. Like before, you got a camera and you got a user ID that was admin and the password was admin, and they did what they did. What happened? They got hacked, and they put all this information, this software in it, and there's millions of IoTs that might be compromised that way. So the use of DNSSEC is being promoted, and the use of this safer way of setting IoTs going forward. It's the industry have to get that going. As simple as the probably the password. Leave the user ID as admin or something else, and the password use the serial number. That's what most of the Wi-Fi systems do, and serial numbers are difficult to change. So that's a couple of things that the industry have to do. But since it's something that is in the private hands, the industries that have to get the act together, and otherwise the internet will keep suffering and having this problem with the botnets running this denial of services.
Yeah, thank you for that. Going back to the question of the new IP, I just posted in the chat a link to where the live stream or the recording of that webinar was held. And it's interesting that some of the questions that they try to address uh, are referring precisely to this. Is it time for a more sweeping change in the standards defining data communication? Is such a change even possible? And you've already answered that, given the inertia surrounding the world's convergence on IP. And that brings me to to the concept of why is it so difficult, besides the economic and the equipment needed, to move from IPv4 to IPv6? Is it because the end users aren't aware that IPv6 offers more advantages or something else?
I think it has to do more with if it works, don't touch it. I think it has to do more like that. You know most of the big corporations are IPv6 ready, but the pages like, for example, you take a GoDaddy. I'm taking this as an example. It's not the corporation itself. I'm using GoDaddy as an example. It's a big corporation that provide hosting services. They don't offer IPv6 because they say the demand is very low, and the actual putting together what they need to do this is too expensive. I mean, you're talking there a hosting company that have millions and millions of pages. They're all IPv4 and they don't offer IPv6. And this is just an example. So if it works there, it has to do with money, equipment. So, you know, uh, even though IPv6 provides extra, other type of things. It's, eventually probably will, with this exhaustion of IPv4, probably people will start thinking about more about IPv6, but I don't know, maybe a new application will come in and they will require IPv6. I don't know. But now it will stay like this. And something I want to say about this new IP, reference to this new IP ideas of providing, do a redesign of the protocol systems. Look, in 1973-74, TCP/IP was created, right? How many people created that? Two, right? Vinton Cerf and Bob Klein, I believe is his name. That was it. If you were going to create a new IP protocol, you had to bring everybody into a table and say, okay, my design is better than yours. No, my design, I need mine because I need to use it to control what's running in the internet easier. How do you get this new design? Who is the right design? You have to get all the multi-stakeholders in one place, and it will take forever or never to create a new protocol that will satisfy everyone. It's not like in 1970s there was nothing. Now it's everyone. So that's another hurdle that will make this not happen.
Well, thank you, Eduardo. I want to remind everybody that in the chat, I posted the link to the survey that we are interested in having you respond to. It's I think it's 4 to 5 questions. It's a short one, so please respond to it as soon as possible. And I told you at the beginning that Eduardo likes to talk a lot, but we made this, believe it or not, a very interesting discussion. There's still more questions, Eduardo, but it's already the top of the hour, and I don't want to exceed the time set up. Now, if you have any more questions, Eduardo is one of the teachers in the course, so you can address the questions directly to him, or you can post them in the corresponding discussion forum, and we'll keep the discussion going. So Rola has seems to have another question. So I told you this was going to be engaging. Regarding to the question about the relation between ITU and IAB, here is a presentation. Maybe it answers your question. So look at that, and thank you, Rola, for that. And yes, it's very helpful. So if you may, Rola, put it in the discussion forum on infrastructure, so that all the participants can see it, and we can keep on discussing about this. Glenn points out that he'll convert it into an ebook, so it'll be available under the complementary resources of this module. Having said that, yes, go ahead,
I have a question. In the courses that you have through the school, do you have something about the ITU that explains what they do and with relation to the internet and internet governance?
Yes, there's a couple of places that you can find that. If you want to get to that, go into the Internet Governance Actors, go to the history, use the tags, and look for ITU, and you'll find all the places where that is discussed from different point of views. So please do that. I encourage you to look for it. Well, thank you, Eduardo. It was very interesting conversation, and I know that we'll keep going in the course as well. So thank you.
Okay.
See you all, and this is the end of this live session. Thank you all.
Thank you all for being here. Bye-bye.